Hello students, welcome back to 60 out of 60 in KCET Chemistry 2025 series in just 200 days. So today we are going to discuss about alkenes properties. Okay, so we have completed in the previous class about alkenes preparation, isomerism, structure and all. Now we are going to discuss some physical and especially the chemical properties of alkenes. Okay, so let's get started here. Okay, so today we are on part 6th, right, where we are discussing the properties of alkenes. Okay, so let me directly go to the class part. Yeah, weightage you can, so this chapter itself carries less weightage, but yes, this chapter is very important, a fundamental chapter for your organic chapters in the second PU. Okay, so you must make sure that you understand these fundamentals in a like very well. Okay, so students, here is a small announcement. As you all know, your PU boards are approaching. Just 3 months are left. I can say not even 3, sorry, 2 months are left. So it's really high time to gear up your preparation, and to help you with this, we have come up with PU2 Success Blueprint Test Series. Okay, so in this test series, you will be getting 12 mock tests, which includes 4 part tests and 8 full-length papers from the subject PCM, Bio or CS. You will also be getting one-shot revision videos, detailed solutions, like video solutions with detailed explanation. Then you will also be getting doubt clarification classes and PDF of the solutions. So now these all things were available at 599 rupees, but here now we are going through a discount. Okay, and if you use the coupon NY2025, you can avail this at just 499 rupees. Okay, so students, please do not delay, do not miss this opportunity, as this coupon code is valid only till Jan 10th. Okay, so you can go to the description section, click on the link given below and purchase the test series before it's too late. Okay, fine. Let's now go to the next slide, where we will be talking about these reactions today. So addition of H2, addition of X2, addition of HX, this is very important. Okay, addition of H2SO4, addition of water, oxidation, ozonolysis and polymerization. Okay, so these are some very important reactions which are we will be discussing today. So first one is addition of H2. This reaction many of you might have already studied. We have discussed, that is hydrogenation. So when you add H2 in presence of palladium or carbon, okay, to a double bond, the double bond breaks and then we get single bonds are like single hydrogens are attached. Okay, so alkene gets converted to alkane. So in the previous class we have discussed that alkenes are less stable. Okay, so that is why they immediately get converted to a more stable product. Okay, so you can use here nickel and platinum also as catalyst. Okay, next we'll go to addition of X2. Okay, so X2 means any halogen like Cl2, Br2, F2. Okay, so now ethene is there, and if you have Br in presence of CCl4, okay, Br2 in presence of CCl4, this double bond breaks and we get 2 bromines added. And similarly, if you have chlorine, okay, and chlorine is there, and if you break the double bond and add 2 chlorine group, so that will be your 1,2-dichloropropane. Okay, next we have okay, here a very important reaction is there, that is addition of bromine water. So see, this bromine is actually orange or red in color. Okay, I can write like red orange color. Bromine water is actually reddish and orange color. Now if you take an alkene and add this bromine water to that, right, so this Br2 molecule is changing, it is attached to this Br like this, so the reddish color of that bromine solution decolorizes. Okay, so that can be used as a test for unsaturation. Okay, it is not a test for alkenes, it is a test for unsaturation, means both alkenes and alkynes will show this reaction but not alkanes. Okay, so the reddish orange color of bromine solution in carbon tetrachloride is discharged when bromine adds up to an unsaturation site. This is used as a test for unsaturation. Okay, now coming to the third reaction, which is very important, addition of HX. Okay, so here we should understand about 2 things. First is symmetrical and asymmetrical alkene. Okay, symmetrical and asymmetrical alkene. Okay, So let me first explain what is symmetrical alkene and what is asymmetrical alkene. So if you see but2ene, okay, and you see propene. Now you see here in the both side of the double bond, equal number of carbons are present or equal groups are present, right? So this is a symmetrical alkene. But if you see here, if I have a double bond here, here you find 2 carbon and here you find only 1 carbon, right? So this is an asymmetrical alkene. Clear this much, what is symmetrical and what is asymmetrical alkene? Now for example, let me just take pent2ene, okay? So if you see here we have 3 carbon, here we have 2 carbon, right? So this is an asymmetrical alkene, okay? This much clear? Fine. Now see what happens when we add HX. So there is something called as Markovnikov's rule. Markovnikov's rule. Okay, please, very important. Okay, now see what does this rule say you? This rule says that when you add HX, okay, in HX, H is the positive part, X is the negative part. Okay, when you add HX to unsymmetrical alkenes, okay, X will attach where? X, the negative part, will attach to the carbon with less hydrogen. Understood? So this statement may be little confusing, but I'll give you an example. Now see, for example, you have propene, asymmetrical alkene should be there. So I've taken CH3, CH, double bond CH2. Okay. Now suppose you added HCl. Okay, now H will add to this double bond carbon, like this one and this one. Now you see in this particular carbon there is only 1 hydrogen and this particular carbon has 2 hydrogen, right? So what does the negative part here? X represents the halogen, so this is the negative part. Negative part will attach to the carbon having less number of hydrogen. We do not have to consider this carbon, okay? Only the 2 carbons involved in the double bond. So Cl will attach to the carbon having less number of hydrogen, that means Cl will attach here and the other part H will attach here and the double bond will break. Okay, so what I'll get here? CH3, then I have CH, CH2, and here I will attach Cl and here I will attach H. Okay, clear? Now I'll give an example of, suppose now in case you want to add Cl here, you want to add 1 halogen here, then how can you do? So there is something also called as anti-Markovnikov's rule. Okay, anti-Markovnikov's rule. But remember, this anti-Markovnikov's rule is applied only with 1 halogen, that is bromine. Okay, so if you use HBr in presence of any peroxide, okay, I won't write H2O2. So in presence of peroxide, examples, you can have HBr in presence of H2O2. Okay, if this is the reagent, then the opposite thing will happen. Means what is the opposite thing here? If I have HBr, okay, what is the negative part? Br. Br will attach to carbon with more number of hydrogen. Clear? So I'll give you another example. Okay, so just let me take this particular compound and add and give you 3 questions and let us solve them. Okay, quickly we'll do it. Okay, so I have propene here. Okay, and these are the following reagents. This side, suppose 1 more. Okay, so here I add HCl, here HCl and H2O2, here HBr, and here HBr in presence of H2O2. Okay, now see, first HCl is there, normal HCl, it will follow Markovnikov's rule. So you can see this carbon is having less number of hydrogen, so chlorine will attach here, right? So what I'll get the product? CH3, CH, Cl, CH2H. Okay. Next, HCl in presence of H2O2. Now many of you might think that it will follow anti-Markovnikov's rule, but I told you that this anti-Markovnikov's rule is only applicable to this particular reagent. No other halogen will behave in this way. So this one will also give you the same product. Okay, so I will get CH3, CHCl, CH3. Okay, next if you use HBr. Okay, now here you see HBr is also will follow Markovnikov's rule. Okay, so in this place what will happen? Bromine will attach. So I will get CH3, CHBr and CH3. Okay, done. Now if we have HBr in presence of H2O2, HBr in presence of H2O2. Okay, so now how will this happen? So now you see HBr is there and H2O2 is there. So which rule it will follow? Anti-Markovnikov's rule. So anti-Markovnikov's rule tells you that bromine or the negative part will go to the carbon having more number of hydrogen. So if you see here which is having more number of hydrogen, this carbon, so bromine will go and attach here. So what I will get? CH3, CH, CH2, here Br and here H. Okay, I hope all of you can see it. 1 second, students. Yeah, so I hope all of you can understand the difference. So this is how the addition of HX works. Okay, now going to the next one, addition of H2SO4. This is also very simple. So if you have, for example, propene. Okay, addition of H2SO4. So the structure is like this. H2S, okay, we want one more H, right? Yeah. So now you see what happens. This one will donate one H plus, right? So this is H plus and this is minus, right? So this is negative part and this is positive part. So here also the general Markovnikov's rule will follow. Sorry, here what will happen? This one, okay, this H plus will attack on this carbon and you will take this one here. So we will get a compound like this, CH3, CH2, CH2, OSO2, OH. Okay, so here what happens? This H gets attached here to this end carbon, this one is attached. Okay, this is simple addition of H2SO4. Now coming to addition of water. This is again very important. So in water what we have? H plus and OH minus, right? So negative part, so this one will also follow which rule? Markovnikov's rule. Okay, so let me just take one example. If you have CH3, CH and CH2 and you add water, okay, and whenever we add water, right, you take some acidic medium, okay, to increase the speed of the reaction. So OH part, the negative part will go to the carbon having less number of hydrogen, right? So what I will get? CH3, COH and CH3. Okay, this is done. Next is oxidation. This is important, oxidation part. So alkenes on reaction with cold dilute aqueous solution of potassium permanganate. This is known as Bayer's reagent. Okay, cold dilute aqueous solution of potassium permanganate, that is Bayer's reagent, produce vicinal glycols. Okay, so what is vicinal glycols? Means when the adjacent carbons have OH groups. Okay, when the adjacent carbons have OH group, we call it vicinal glycols. So here you can see ethene is there, H2O, and that is oxygen in presence of dilute KMnO4. If you use, we have this OH and OH group. So it is ethane 1,2-diol or glycol. Now similarly, if you have propene here, H2O and dilute KMnO4, if you use, the two carbons present here will take the OH group. So OH group is attached to where? The double bonds, right? The double bonds are shifted to OH and OH like this. Okay, so you will get product like this. Okay, so that is what the reagent used here is Bayer's reagent or dilute KMnO4. Now there are certain more oxidation reaction also if you just use normal, like not dilute or not cold KMnO4. Okay, so generally in case it is used hot KMnO4 we say. So if potassium permanganate or acidic potassium dichromate oxidizes the alkene to ketones and or acids. Okay, so we have like this. We have like this. Okay, Now if you oxidize this one, okay, so this one will get converted to C double bond O, okay, CH3 C double bond O plus CO2 plus H2O, okay. So you have CH3 C double bond O plus CO2 plus H2O, okay. So this part gets converted to like this, okay. This is one way. Now another, if this alkene is present in between, like you can see this is called terminal group, means in the last carbon we have double bond. If that carbon or the double bond is present in between the chain, then what will happen, each one of that will form one acid, okay. So here it breaks, this one will give you 2 carbon acid, this one will also give you 2 carbon acid, so we get 2 acetic acid, remember. So if there is an double bond in the last carbon, like before in the last carbon, then that is eliminated and we get a O in place of that. But if it is in between, then you break it and both the sides are converted to acids, okay. Fine. Next is ozonolysis, okay. So sorry, this one second, okay. Okay, so this is different, this is the previous one, so we don't have to discuss. So what is ozonolysis? See, lysis means anything which you break, okay, and if you break it using ozone, okay, then it is called ozonolysis. Now for what is the reagent used for ozonolysis? Zinc, okay. So you use Zn water to form smaller molecules, right. This is very interesting. Now see, suppose you have like this CH3 CH double bond CH2 and you use O3 in presence of Zn water. Now what will happen, this bond will break, okay. Now this one will get converted, so you see it is like this, CH3 CH is there, this one you have to attach a double bond O, and here also you have to attach, like CH2 is there, okay, and you have to attach one double bond O here. So this will give you one alcohol, this is also giving you one, sorry, aldehyde and aldehyde. Now let me take one more example, okay. So let me do here, suppose I have CH3 CH3 double bond CH2. Now if I use the same reagent, I am not writing the reagent again and again, this one will break, here a double bond will come, right, plus here what will happen, okay. So this one will give you one ketone and one aldehyde, okay. So now we have polymerization, okay. So polymerization is like the large molecules thus obtained are called as polymers, okay. This reaction is known as polymerization, okay. So means polymers means what, many small compounds or many small molecules gather together to form a polymer, and the process is called as polymerization. So generally ethenes, you have very frequently used polythenes, right. So that is a polymer of a monomer, that is ethene. So when you take ethene at high temperature, pressure and catalyst, okay, so that will give you polyethene. Similarly if you have propene, so that will give you polypropene, high temperature, pressure and catalyst, okay. Fine. So that's all in this class, student. So we have discussed, so let's first revise the reactions that we have understood today, okay. So addition of H2, we just know what are the different catalysts we can use, nickel, palladium or platinum, right. Then for addition of X2, you can use Br2 in presence of CCl4. And what is extra thing you know about this one? This is a test for unsaturation. Next here HX, you should remember about Markovnikov's rule and anti-Markovnikov's rule, okay. This is not very important reaction. Here also it follows what? Markovnikov's rule. Here oxidation, you should know there are two things, one is cold KMnO4, okay, cold KMnO4 and hot KMnO4, okay. So cold KMnO4 is your what? Bayer's reagent, okay. This one will give you aldehyde, this one will give you acids. Next ozonolysis, zinc O3 in presence of zinc and water, okay. Reductive ozonolysis. Polymerization we have discussed. So yes students, that's all in this class. And now I have already told you about the test series, what all things are there, so I won't repeat it. But yes, some important things, that the coupon that can be used to get rupees flat 100 off is NY2025, and this is valid till Jan 10. Okay, and if you avail this coupon, you can get this test series at just rupees 499. So please do not miss this opportunity. Go to the description section, link is there, and purchase this as soon as possible. Okay, fine, that's all in this class, students. I hope all the reactions we have revised, but do not worry, we will be doing more questions also. Okay, so very soon we will be doing questions. So I am taking very small parts of this chapter so that we can devote like less time and complete all the concepts. Okay, thank you so much, and see you soon in the next class.